Imagine a black hole, tiny, invisible, and moving at the speed of light, racing straight through our solar system. No warning, no time to prepare. One moment, empty space. The next, the most destructive object in the universe passing right beside Earth. At first, nothing seems different. A black hole moving at light speed would be almost impossible to detect. No glow, no sound, no shadow, just a distortion tearing through space-time. But then the first effects begin. The moment it enters our solar system, gravity itself bends. Planets shift millimeters off their orbits, and those tiny shifts trigger massive chain reactions. Saturn's rings begin to wobble. Jupiter's moons drift out of alignment. Even the sun's outer layers tremble, pulled by a force stronger than anything it has ever encountered. And then it reaches Earth. A black hole doesn't need to hit our planet to destroy it. Passing nearby at even a few million kilometers would unleash chaos. Within seconds, Earth's crust begins to stretch. Tidal forces tug at the planet unevenly, causing earthquakes in places that were stable for millions of years. Entire continents shake as the invisible visitor tears space around us. The atmosphere distorts next. Air pressure drops in some regions and spikes in others as gravity warps in real time. Winds accelerate to impossible speeds. Storms appear instantly. Massive supercells born not from weather but from space-time being pulled like rubber. Oceans rise. Literally. Water begins lifting toward the black hole's passing path, creating tsunamis that stretch hundreds of meters high. They crash back down with catastrophic force, obliterating coastlines across every continent. Then comes the strangest effect: time dilation. For a brief moment, time on Earth slows compared to the rest of the universe. Electronics malfunction. Satellites drift off course. GPS collapses. Communication signals warp. In some regions, clocks desynchronize by entire seconds, an eternity for modern systems. But the most dangerous moment is still ahead. As the black hole passes closest to Earth, its gravity briefly competes with the sun's. This tiny shift is enough to knock our orbit off balance. Earth begins drifting, just slightly, but enough to change the climate forever. Winters grow colder. Summers grow hotter. Seasons stretch weirdly. Plants and animals struggle to adapt. If the black hole passed just a little closer, Earth could be ripped apart completely, pulled into a long stream of vaporized rock, spiraling behind the black hole like cosmic dust. Humanity would vanish in milliseconds, but in this scenario, Earth survives. Barely. The black hole shoots away into deep space, leaving behind a planet permanently scarred. Cracked coastlines. Collapsed cities. A tilted orbit. A broken climate system. Humans forced to rebuild under a sky that now feels unstable and unpredictable. Scientists would spend centuries studying the event. But one truth would haunt humanity forever. The universe is full of invisible objects traveling at unimaginable speeds. And if even one of them passes too close, life on Earth can change or end in a fraction of a second.